Doing 3.4, problem 1. So similar to example 1, we want to find the derivative of this particular function, 6x squared minus 5x minus 1. We want to use the definition of the derivative to do this. So remember what that is. F prime of x is defined to be the limit as h approaches 0 of f of x plus h minus f of x divided by h. All right, so if you remember the sort of steps that we have to take here, the first thing we want to find is f of x plus h, and then we want to simplify that. So f of x plus h be whatever we get when we plug in x plus h in for every occurrence of x within the function. So basically just replace all the x's with x plus h's, and then we'll simplify that. So remember again that this is a binomial squared, so we write it twice, FOIL it. So we're going to get 6 times x squared plus 2xh plus h squared. The second term will distribute the 5. We get minus 5x minus 5h, and then we still have the minus 1 on there. If we distribute the 6, we're going to get 6x squared, 12xh, 6h squared, and then the rest of it. Okay. Now we want to do f of x plus h minus f of x. So next step is take what we just found, let's that up a little bit, fix that, f of x plus h minus f of x. So we just found that all of that is f of x plus h. So we'll just write it again, 6x squared, 12xh, 6h squared, minus 5x, minus 5h, minus 1. So that is all f of x plus h. Now minus f of x. Now remember, we're subtracting the whole function. That's the function, so we have to put the thing in parentheses. So we're going to get 6x squared minus 5x minus 1. And let's simplify that. All of this minus the whole thing there. If you distribute that, I'm just going to go ahead and write above it what we get when we distribute the minus. This is going to be minus 6x squared. If I distribute the minus there, I'm going to get plus 5x. And then there, I'm going to get plus 1. Okay, so let's just say we've simplified that, and then let's go ahead and cancel out our like terms. So we're going to have, so basically, all this is that now. So 6x squared minus 6x squared. So that and that are going to cancel. What else is going to cancel? We have a minus 5x here, and we have a plus 5x here. We have a minus 1 here, and we have a plus 1 here. And if you're doing this right, this is what should happen. You should have a whole lot of terms cancel. In fact, the only terms that don't cancel, as we see here, are the terms that have the h's in them. So we should expect to see that kind of thing when we're doing this. So fully simplified, we're going to get 12xh plus 6h squared, and then we have that minus 5h still. Okay, so that is f of x plus h minus f of x. Now remember, the next thing we want to do is find f of x plus h. I'm going to go ahead and just put the limit in front of here because I'm running out of room. Take the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now all of that, the numerator, f of x plus h minus f of x, that's this. That's what we just found. So we're going to have the limit as h approaches 0 of 12x. And actually, let's go ahead and take that, and this is what's in the numerator, but we notice that we have an h common to all the terms. We can factor it out. And then we divide by the h that's there. And the reason for factoring it out, you see that those are going to cancel. Finally, we can now take the limit with what's left over. This is what's left over after we canceled. If I take the 0 and plug it in for the h there, what's left? I'm going to be left with 12x minus 5. So that's the derivative. That's f prime of x. This is f prime. Okay, then it says also to find f prime of 2, f prime of 0, and f prime of 3. So f prime of 2 would just be what we get when we plug in 2 to that right there. So that's 12 times 2 minus 5. So that's 24 minus 5, so that's 19. So that tells us that if I were to graph this function, however, on the calculator or whatever, when I go to x equals 2 and I look at what a tangent line would look like, it would have a very steep slope. 19 is very steep, so the tangent line would be pretty close to vertical. Then f prime of 0, that would be what we get when we plug 0 into that. Well, if I plug 0 in there, I'm just left with minus 5. So that's telling me that, again, if I were to graph the original function and look at what's happening at 0, if I were to draw a tangent line there, I would find that it has a negative slope. And finally, f prime of 3, that's just whatever I get when I plug in 3. So 12 times 3 minus 5. 12 times 3 is 36, minus 5 is 31. So that's a very steep slope, even steeper than what it was at 2. That just means if I go to 3, x equals 3 on this graph, I'll find it has a very steep slope. It'll be almost a vertical line slope.